Welcome. On behalf of the AIA Potomac Valley CRAN Committee, which is produces program for everybody, and we are doing that on behalf of the Tri-Chapter Capital Area CRAN, which is something started in 2013 to serve architects, residential architects, specifically custom residential in the DC area. And is comprised of AIA Potomac Valley together with AIA DC and AIA Northern Virginia. So we are very glad to be bringing this program to everybody because this is a subject I dare say most of us have not re-examined too often in our careers, and it's about a very important part of the project, obviously, which is as-built drawings, getting them right. And so we'll be talking about the whole range of, or our presenters will be about the whole range of ways to do that, including some new technology that they're going to educate us about. And I'm very excited to be part of this program because I'm very eager to know what's out there and better ways to do what we're doing. So without further ado, I'd like to say thank you to our chapter sponsors who've made it possible for us to do great CRAN programs for residential architects, including, of course, the presenters, Precision Property Measurements, and Variances, and TW Perry, which are area suppliers that we all know. And moving along, I will introduce you now to our speakers, who are Justin Yoder, who's the Regional Director of PPM, and Colin Maloney, who's gotten up early to present to us. He's way out in California, and he's the Regional Director for the Bay Area. Thank you both for presenting, and looking forward to hearing from you.
Thank you, Helen. Thank you very much for introducing us. And as Helen said, I'm Justin Yoder. I'm the Regional Director for the Mid-Atlantic region here out of DC. And I'm joined by my colleague, Colin, from the Bay Area of California.
Hello, everyone.
And this slide, I know Sue already mentioned it a little bit, but I'm going to required reading here is credits earned on completion of this course will be reported to the AIA CES for AIA members. Certificates of completion for both AIA members and non-AIA members are available upon request. Please go ahead and email or chat to pam@aiapv.org to get that. This course is registered with AIA CES for continuing professional education. As such, it does not include content that may be deemed or construed to be an approval or endorsement by the AIA of any material of construction or any method or manner of handling, using, distributing, or dealing in any material or product. Questions related to specific materials, methods, and services will be addressed at the conclusion of this presentation.
Justin, if I may, I just want to remind everybody to mute if you're not speaking during this presentation so that everybody will be able to hear well. Thank you.
Thank you, Helen. So the next two slides are going to be covered for the most part in the actual presentation, but as part of the AIA CES, here's a little bit of information about the course. And here is a slide about the learning objectives, which we'll actually get into in the next slide as we start the presentation. So what are we going to talk about today here? There's going to be 4 objectives. The first is what are as-built plans? We'll cover some common definitions, when as-built are needed, gathering various degrees of information for producing as-built, and when projects require a detailed scope. Then we'll cover some traditional surveying methods, such as sketching, the plan view measurements, and the Z-axis. Then we'll get into the new era of as-built laser scanning. We'll talk a little bit about terrestrial scanners and mobile scanners, as well as what the data output is of those, the point cloud, and how to use that point cloud. Then we'll talk a little bit about creating an as-built set, drafting from the traditional method, and drafting from a point cloud. Throughout the presentation, we are going to have a series of polls or questions in which I'll ask you either a multiple choice question or an open-ended question. And at the end, with what time we have, we can open it up for questions if there are any time. So let's get started. What are as-built plans? Some common definitions that we'll cover are, when looking into the actual definition of an as-built plan, one will mostly find is a definition that concerns as-built plans being created after or during new construction, or after or during a renovation. The definition here is as-built drawings are prepared by the contractor. They show in red ink on-site changes to the original construction documents. They are more like interpolations done for construction purposes. Therefore, the changes that a contractor makes onto the original design are called as-built drawings. Contractor developed as-builts should not be construed with record drawings, created, of course, by the architect or engineer. Record or archive drawings often include the information gathered on as-builts and are the final set of formally developed prints, fully signed and stamped by the project engineer or architect. This definition reads, record drawings are prepared by the architect and reflect on-site changes the contractor noted in the as-built drawings. They are often compiled as a set of on-site changes made for the owner per the owner-architect contract. This is not always mandatory and created, but in general, some formal architectural services create these as one of the late tasks of a building project. And of course, everyone here takes the time to do this on every project, right? So the first audience question we have for you, and please share this in the chat, is what terms do you and your team use to describe as-built plans? I'll give a minute or so here for people to type in what they use for terminology. Existings, that is one I've heard a lot out here on the East Coast. As-builts. As-builts, existing condition drawings, yep. All of those are ones that I typically hear out here, existing conditions. Thank you, thank you. Are there any others? Plans drawing of the existing house, thank you. Thank you. Provided by contractor, CEC. All right, cool, cool, some good answers. Measure drawings, all good answers. All right, so we're gonna start moving on here. You can continue to keep putting answers in the chat if you'd like. We can look at them later if we have time. So again, what is an as-built plan? So let's just keep this simple. In the architecture and construction industry, as-built refers to a drawing that shows the existing dimensions and conditions of a building, space, or area. So what is then an as-built survey? It's simply the entire process of measuring and drafting or modeling the as-built plans. Before we get any further though, I want to say that throughout the presentation, we'll be discussing producing as-built plans in their final format as either 2D CAD files or a 3D Revit model. Both are softwares created by Autodesk. As you likely all know, there are many, many other drafting and modeling softwares out there. So even though we're mentioning Autodesk software, it's likely that you can apply any points that I make about 2D drafting software to all others on the market, as well as 3D modeling software such as Chief Architect, ArchiCAD, Vectorworks, etc. So what are some contributing factors to when as-builts are needed? Pretty much whenever we're working with an existing building, we need as-builts before starting design. If the owner or client happens to already have as-built drawings, then we may just need to enter them into CAD or reformat them if they are already in CAD, and confirm that the drawings are up to date. If errors or inconsistencies are found, then at some point, you may decide that a fresh set is needed. So what are some contributing factors to when as-builts aren't needed? It is rare that clients already have current as-built of their existing buildings that are accurate, but it does happen. So in that case, of course, you would not need more before starting your project. There are also simple cosmetic projects that do not require having as-built. And of course, if a building is being built from scratch, then all you'll likely need are the construction documents. So when is the best time to obtain as-built plans? In most cases, obtaining as-built files is one of the very first steps in the renovation process, if not the first step. Getting ahead of this step allows an architect to focus on their design, plan creation, and submittal to the building department, all of which are considerably more time-consuming than that first step. There are also cases where you'll be working with a historic review, and they will require as-built to be created. And if you are working on a teardown project, some building departments require you submit as-built of the structures being demolished. As mentioned on the previous slide, different municipalities work differently and have different requirements. If they require as-built for any reason, the type or the scope needed may vary from city to city. If you plan to preserve or improve upon detailed architectural elements, such as ornamentation, you'll need to consider that documentation and where it fits into your timing. Overall, the size and scope of your project will determine when as-built are needed. And as we'll discuss in the next section, to what degree the detail and scope of as-built are required. So you've discovered you'll need as-built. How far and in how much detail do you need your information to go? What types of plans are needed based on the project? Above are a few examples of plan types and when they're needed in your as-built plan set. For example, most of the time, you will likely need floor plans. However, if your work impacts the exterior, such as a facade renovation, a historic facade, or window replacement, etc., you might need exterior elevations. However, if you're working with an existing structure where you might be into some height constraints, such as attics or basements or crawl spaces, or in the district, you're dealing with District of Columbia height requirements for the building itself, you might need sections. Or if you're modifying existing lighting, or there are unique ceiling conditions such as coffers or trays, or perhaps exposed structural elements, you might need reflected ceiling plans. It's ultimately up to you as the architect to decide what the scope should be for your as-built plan set, or consulting with your engineer as well on what might be needed.
Because I'm doing a seminar.
While you're showering?
Can we please mute?
It's a continuing education grant.
Before we get into specifics regarding plan types, let's go over some of the ways to gather on-site information, starting with a very simple, quick method, and then ending with full-blown as-built plans. Okay, so now we know what we need and why we need it. Now, how do we get it? One way to obtain the answers you need on site before renovation is by simply taking photos. This can assist in the design process and answer questions you might have before proceeding. However, sometimes a quick single line or even a bubble diagram is all you might need to achieve your goals. This can be achieved quite quickly on site and does not need to be to scale. Sketching can be very helpful in supporting your design in the case of interior elevations or perspectives. This can also be done roughly and may not require a measurement. If drawings need to be to scale, such as when they'll be used to create new construction documents, then you might need to go to a higher level of accuracy and measure the existing conditions. Most remodel projects require a more detailed scope for as-builts. This will give you a head start in the creation of your design, submittal, and construction documents. In summary of the first section, we learned that as-built plans, simply defined, is a set of plans of any structure as it exists at that moment. They're most often used for a renovation of some type. We've also discussed getting as-built drawings in the format in which you work is important, such as a particular software. And the scope of the as-built plans and the detail of each scope item will vary with the needs of your project. Now I'm going to turn it over to my colleague Colin. He's going to talk a little bit about traditional surveying methods.
Yes, thanks, Justin. And apologies ahead of time. My office is next to the Oakland airport. I'm out in the San Francisco Bay Area and a plane might fly over. So I'll try to talk louder when that happens. So now we'll talk about an as-built production method that's near and dear to my heart, sketching, which I've done for probably the majority of my as-built creation career, as opposed to the other methods we'll talk about later. So sketching, here's how you might sketch. First of all, remember that sketching does not need to be to scale. All you need to do is make sure that there's room to write in the measurements that you need and that it's visually easy enough to follow when you're back in the office. You can use different colors on your sketch to mark different measurements so that your eye catches each segment accordingly while you're drafting, and you don't spend all that time hunting for little things on your sheet. Get as much sketching done as you can before you measure so that you can just focus on measurement when the time comes and execute those measurements. The better your sketch is, the easier your measurement will be. If it's sketched correctly, any structure can be measured quickly than if not. Leave room to write in your measurements and plan ahead to get your heights or measurement on the Z-axis. Most of the time, this information can still be displayed in plan view, but occasionally you'll want to sketch in section or elevation view. And we'll talk about this again in the next few slides. Sketch out any details or ornamentation to the degree of precision you desire to be able to add those measurements later. All right, now it's time to add those measurements to your sketch. So an important step that many people skip when measuring a structure is going around those exterior faces. Often a wall thickness is taken at an exterior wall and then the interior measurements only from there on out. But I consider this step to be crucial. Start by measuring all the lengths 360 degrees around. And to check your work, you'll want to add up all the X and Y values. See that lower right corner on this sketch? You'll see that you did the math to add up the values on each side. And this, of course, can get complicated if your structure has curved or angled walls that aren't 90 degrees. But adding up all the X values and all the Y values and having them come very close will mean that you're on the right track. In this sketch, you'll notice that there's some overall measurements as well as small incremental measurements. The overalls are in red and the small incremental ones are in pencil. It's a good system of checks and balances that will not only improve your overall accuracy, it may save you in the event that you have an incorrect measurement or notation. Don't forget to get good photo coverage as well. That will help you verify that what you're drafting is indeed correct. Occasionally, I've seen errors that don't appear as errors on paper, but they're very obvious when you're looking at an image as well. On this sheet, you can see that we have the previous sketch below, and then there's a sheet of vellum on top of it. This allows you to use that information from the first sketch, such as the wall layout, doors and windows, and then add even more symbols to that in different colors that you've designated for your plans and showing symbols that you'll be able to recognize when you're in the office drafting. So now let's talk about collecting the Z-axis measurements or height information using these traditional methods. You can use a tape measure to measure all the risers in the stairs, or drop it down a balcony, run it up a wall, etc. A laser disto can perform trigonometric functions instantly and get you heights in all sorts of ways. So the first of these two tools you might already be using to measure the other aspects of your plan view on the X and Y axis, but this third one is used exclusively to get height information. It's called a zip level. This is an excellent tool invented.
No, I haven't talked to him yet.
Excuse me, don't forget to mute, please. I know we're all excited about the zip level. This is an excellent tool invented, distributed, and repaired if needed by a company out of San Diego. I'm not aware of any other version of this tool.
Okay, you want to?
Yeah.
Okay, so I'll just leave that with you.
Yeah.
Okay.
It uses displacement to read heights anywhere
Yeah,
within
wouldn't
a
that be cool?
50-foot range.
Yeah.
Can we hunt down? I think it's JP Ward maybe that was talking. I'm not sure, but please make sure you're muted. Okay, so moving right along. However you've collected your height measurements, you got to make sure that you have them in the places that you'll need them. Most of the areas will be obvious, like the tops and bottoms of the staircases. You want to get those floor to floor heights and any change in finished floor height. And you can see in this quick sketch, it's just a plan view drawing, but it's showing those height differences with some notation. So plan on what you'll need to see in those exterior elevations ahead of time and sections. Make sure you either have some height and pitch information for your roof or every height that you can get on the roof if it's safe to climb around up there. Make sure not to forget the heights of openings such as windows and doors and headers, and the heights of things like a sconce on the wall if you plan to produce those detailed interior elevations. Here we see a quick sketch of a roof, and it's got some height readings that were taken with using that zip level we talked about earlier. So to sum up the second portion of this presentation, having the perfect sketch isn't important. What you need is a sketch that displays and contains all the measurements you'll need in drafting. It doesn't need to look pretty either. You need to encapsulate the structure by measuring all the way around it. This will give you the correct scale when you begin drafting and ensure your interior measurements are correct as well. After taking the measurements of more major items like walls, doors, and windows, then you can move on to the next level of detail as needed. This can be for cabinetry, plumbing fixtures, or even electrical and ceiling components. And now I'm going to hand it back over to my colleague, Justin, and we're going to talk about some of the new era stuff to obtain this as-built information. Take it away, Justin.
Thanks, Colin. The change to completely new technology and ditching some, if not all, of the traditional methods isn't easy in any industry. But using LiDAR allows for fast data acquisition performed by a skilled surveyor using 3D laser scanners. It's also more accurate than any measurement that can be taken by hand. This technology can be purchased, rented, or contracted. It's a thorough solution. It allows surveyors to gather more data than needed to complete most projects. And it provides a digital twin to pull additional data down the line if the project ever needs to be revisited or if additions need to be made to the scope of work. Here are some examples of each type. The terrestrial or standing scanner on the left, the Leica BLK 360, or the mobile walking scanner, the Geoslam Zev Revo on the right. Either way you choose to go, you'll be using LiDAR to create a point cloud. LiDAR is a method for measuring distances by illuminating the target with a laser light and measuring the reflection with a sensor. Each one of those illuminations then can be considered a measurement. Each single measurement is then logged, and throughout the course of the scan, millions of measurements are taken in every direction. So let's talk for just a minute about a terrestrial scanner I'm familiar with, the Leica BLK 360. Overall, you'll find that the terrestrial scanners, like this one, will give you a much more rich, dense point cloud than a mobile scanner would. Some terrestrial scanners offer extremely high levels of precision to their clouds. In the next slide, we'll see a short video of a scan of a single family residence done with this scanner. As you can see, it collects a lot of data all around as you scan. This scanner picks up color as well and has thermal detection capabilities if you're interested in measuring for that kind of thing. You can see that it has the photorealism with the material color so that you can actually see almost in photoreal quality. And this reprocesses as it's moving, so you see that it gets crisper as it stops moving. Now we can talk and touch on a scanner that I'm most familiar with, which is a mobile scanner, the GeoSLAM Revo. The trade-off for a less dense point cloud or a hyper level of precision is that with a mobile scanner, you greatly reduce your time on site scanning and increase your mobility greatly since you're moving and the scanner does not need to be mounted to anything. In fact, you can even mount other equipment on them, such as a GoPro camera, or mount the camera itself to a drone. Next, we'll watch a short video displaying the output from a scanner like the one you see here. You may notice that the coloration of materials is not included like the Leica, but it does have a height ramp visibility where different heights are shown as different colors on the spectrum. You can see here the green to the blue. The cloud is a little bit more fuzzy, but it still has millions of points and it still collects a lot of data. This is a single family residence, even though it is very large, and one family, believe it or not, lives in that large property. Scanning with a mobile scanner is preferable if your time on site is limited in any way. Mobile scanning can give you the ability to not only scan the project quickly, but also have time to process the scan on site. Once the scan is then complete, you need to process it using the software that is essentially an algorithm that interprets all the measurements and arranges them into a point cloud. So now let's talk about this infamous point cloud for a minute. Reviewing your data well before attempting to create a set of as-built from a point cloud is a must. If there are any kinds of errors with your cloud, which do happen, then using that bad data can either stop you in your tracks later when you're drafting or modeling, or even worse, result in an incorrect set of as-builts. Once your scan has processed, you'll need to review the output. Did you cover all the areas? Did all the rooms get covered? Are there any gaps in the data? Are there any flaws or errors, such as drifting? Make sure to look for any of this drifting, which can occur when the software has trouble putting all the points together. If it occurs, then you can try some reprocessing options or simply scan the structure again. Drifting is common with mobile scanners, and it occurs for several different reasons. Determining which reason is helpful before attempting to reprocess or rescan your project. This picture here is a great example of what drifting looks like in the point cloud. When scanning attics, foundations, large sites, or multi-level structures, etc., that's when you may run into issues with the cloud and the scanner. Areas that are harder to access or have less unique features, such as repetitive hallways, or if a space has lots of reflective surfaces, those can cause issues. Processing requires all the areas have data connecting one area to the other so that they can be properly glued or stitched together. Mirrors and moving objects, etc., can also trick the process and therefore give you a bad output. Most scanners have a pretty far range and will shoot out the windows, and when they're outside, pretty much all over the place. You may need to clip or crop the cloud to reduce the size and then delete the unneeded data. If you have to take multiple separate scans for whatever reason, then knowing how to merge those separate clouds together is useful. Much like traditional methods of sketching and measuring, properly scanning a structure takes lots of practice to do it correctly and efficiently. So how do we use that point cloud now? Now that you've processed and reviewed the outcome of your point cloud data, you'll need to do one of the following things. Do it all again if it came out poorly and can't be reprocessed. Or if it turned out well, go back to your drafting and modeling station to get started with the next phase. which is in order to produce items such as a floor plan, you need to be able to slice the point cloud into a desired section and work from that. Most of the software allows you to do that pretty easily. In addition to cutting sections, you'll need to be able to move or rotate the cloud around to give you the working angle that you desire. So in summary of the third section about the new era of data collection for as-builts, what did we learn? We learned scanning your project can reduce errors and time spent on site. The type of scanner you use will be dictated by your needs and level of detail required. And your scanner will create a cloud made up of millions of points. Knowing how to manipulate it is crucial. That way it will have utility once brought into your preferred software. And as an added note, my perspective has been that almost overnight, as-built production methods have shifted from traditional, done that way for decades, to utilizing the latest in laser technology. As with every new introduction of production methods, there's a learning curve, but once mastered, the entire process gets much smoother. When incorporated with BIM technologies, the entire construction process can get a boost in speed, efficiency, and a lesser environmental impact. All right, now I'm going to turn it back over to my colleague Colin again for talking about how to create an as-built plan set.
Thanks, Justin. So now that you've collected the measurements in the field, it's time to create the actual plan sets. So it's important to keep these organized and concise, but at the same time, leave all the room for your notes and your building codes, etc., so you can be used for your design layouts, your demo plans, your construction documents, etc., as discussed earlier. I know we've been recently talking about scanning, so I'm going to ask that you shift gears back to that traditional method for a minute. And we'll talk about how to translate those sketches that we made into great as-built plans. So prop your sketch next to your computer. It's a pretty straightforward process. You're going to use vector-based drafting software to draft at full scale, entering the actual measurements from your on-site sketch. If you're modeling in Revit from a sketch, it's more difficult, but it's not impossible. You're building rather than you're drawing. So you'll often find that you need to let the model dictate certain measurements rather than using your own, just bend them a little bit. For a floor plan, you'll primarily be using the line tool in combination with whatever blocks you've created. And again, we're talking about 2D drafting now. The perimeter line usually comes first, the first thing that you measured in the field as well. Next slide, you're going to want to go ahead and draft all of your walls first, and then put in all the windows and doors. We call that stuff kind of control. If there's multiple levels, you'll need to draft when using your measurement. You'll only need to draft using your measurements, but then you'll also want to be cognizant of those stairwell walls and the exterior faces of the structure to make sure that they line up exactly as they do in real life. So once those controlling items are done, you can draft in with perhaps a lesser degree of precision the cabinetry, the plumbing fixtures, appliances, etc., into your drawing. For an electrical and reflected ceiling plan, it's much the same. Just follow what you've sketched and measured and add the items in one by one. So now we're looking at a roof plan. You'll need to at least have sketched the behavior of the roof correctly in the field, or by using a nice clear satellite photo. This means all of those hips and valleys and ridges, the directions of the slopes. This and the measured length of that overhang should get you to a place where you can draft the roof in plan view. On the same sketch, you'll also need to have collected all the height information. This is often achieved by using the zip level, which we mentioned and showed you earlier, and actually getting on the roof to take all those needed heights. There are other methods, though, such as using an angle finder or a level, torpedo level, digital level, and using those various functions of your disto laser as well. Drafting and elevations will come entirely from your floor plan and your roof plan sketches. The only exception is those special sketches which show certain aspects of ornamentation on the exterior. You may have gone into detail there. Drafting elevations will entail just placing all the windows and doors correctly with the correct heights. And of course, it's important to ensure that they correspond directly with the floor plans in all those cases. Any decorative items you sketched and measured can be drafted as well. Drafting a roof in an elevation view is one of the most difficult challenges, and it needs to correspond perfectly from left to right to all the other elevation views. Once the cut location and direction are determined, you can use the floor and ceiling information you've sketched and measured on site to complete the section view. To draft the roof properly in section view, it's highly advised that you have your elevation drawings finished first, and then you can use them, you can drag lines from them to finish off your section. So now we can shift our thinking back to the scanner method and doing this work using the point cloud we've created. And we'll talk about creating a plan set from that. If you've used laser technology to measure, you'll be drafting from a point cloud. This can be imported directly into your CAD or Revit software. Autodesk requires that you use another software called Recap to prepare the point cloud for the import and ensure it works with their software. Drafting from a point cloud in CAD is pretty straightforward, but it takes getting used to. Modeling from a point cloud in Revit has a few less options. There are lots of options in CAD to adjust the cloud in several ways, and you'll need to use the view cube to rotate your UCS orientation properly to work with the cloud in different positions. Since the entire program is focused on modeling for now when we're talking about Revit, that program is entirely focused on modeling from a particular view range. It allows you to manipulate your model and the cloud simultaneously. Thanks, Justin. First, we can talk about drafting the plan view items from a cloud. When drafting in CAD from a point cloud, you want to ensure that your cloud is positioned orthogonally so that you can use the ortho function in CAD to draw your lines. Positioning the cloud on the Z-axis in CAD is also desirable for several reasons. You should be able to derive all the walls, doors, and door swings right from the point cloud. Window information can be found as well when you're skilled at reviewing your clouds. Many scanners will not pick up smaller items, especially if they're flush with the walls or the ceilings. Trying to locate them in the cloud can be very time consuming. It's possible, but it's oftentimes better to revert to the traditional method while you're in the field and just sketch and measure all those things, and draft them in that way. Now let's get into drafting other views such as elevations from the cloud. This is where there's a huge advantage in having a complete point cloud for drafting. Provided that you were able to access the roof and scanning, you'll have a complete picture of not only the roof behavior, but also every height you'll need to properly draft your roof, exterior elevations and sections as well. As with the electrical and RCP components, sometimes it's beneficial to sketch and measure those ornamental things that might not show up so easily in the point cloud, and then add them in your drafting. So now let's talk about the Revit as-built model. So first we need to touch on the level of development system. It was created for the AEC community to put standards on BIM drawings. It rates the precision, detail, and overall refinement you can take your model to. With level 100 being the lowest, meaning you just mass your objects roughly, and level 500 being the highest, where it's so detailed and exact, you're essentially building a virtual version of your structure. When modeling as-builts, LOD 2 to 300 seems to be the applicable range since you're assessing a structure that has been built from the outside. All those interstitial spaces are inaccessible, and their construction cannot and should not be assumed. When electrical and RCP elements are needed in your as-built model, They will likely be drafted in the plan set in a similar way to CAD rather than in 3D Revit. The items are placed correctly in their 3D locations, but they may not have 3D functionality themselves. Revit has many tools to build site plans and add topography if needed. If you only plan to model as-built of a structure, you may want to limit your site work to the areas that surround or touch the structure only, if at all. In the case of exterior elevations like this one, you want to make sure that the finished grade is accurate along the face of the house. This can be achieved without going into all of Revit's topography tools and instead just using some drawing tools. There are some advantages to having a BIM as built, which some may not know. Sometimes a three-dimensional model is only considered for presentation or design purposes, but it also can be useful as an as-built as well. The as-built BIM model has already the existing phasing, so you can dig right in and start a project to use the powerful phasing tools to show demo and proposed. There's no time wasted moving from the design phase to the construction documents phase of a project using this 3D softwares. Having an as-built BIM model can make it easier to understand a project that you haven't visited yourself, since you can cut those sections and view the existing spaces and roof massing in 3D. Some say Revit offers a more intuitive design experience and allows users to present 3D images at the planning stages to the owner or planning departments. So to sum up the fourth portion of this presentation, drafting from sketches into CAD is a pretty straightforward process. It takes time to become efficient, but you'll just be entering measurements into CAD straight from your sketch sheets. Modeling into Revit from sketches can be done, of course, but you may find that during the modeling, you'll need to ignore certain measurements in lieu of letting the powerful software just build the model properly. Drafting from a point cloud in both CAD and Revit means that you'll be importing the cloud itself directly into the software and essentially tracing or placing components right on top of the cloud to create your set of plans.
All right, this concludes the American Institute of Architects Continuing Education System course. Thank you. I want to thank you so much for coming, and I hope you were able to gain some insight into the subject I'm so passionate about. We do have an audience question I'd like to ask quick, and then we'll jump right into the Q&A since we don't have a ton of time here and we're almost up to our hour. But audience question, just type your answer in the chat. Approximately how long would it take your team to measure and draft a 1,500 square foot single family residence? Everybody's so quick, it's 0 time. Oh, there we go. 6 to 8 hours, 32 to 40 hours, 4 hours, wow, 4 to 5 hours, 1 hour, 8 to 10, 12. We've got quite a range here. That's quite a range. It's
We
good
need
to
to
see
hire that person that can do it in an hour and make sure we get their info.
Right, exactly. Sweet. Thank you, everybody, for the input on the Q&A. Repeat how to use a zip level. Why don't we go right into the 2 questions? I know we had a question from James. Abby, can you reread for me what the question was from James? I think it had to do with the 360 camera, and then we'll get to the other question about the zip level.
Sure, Justin. His question is, what is a 3D camera? He said he believes Leica makes one. How can it be used, and what is the cost?
Sure. If you're referring to just I don't want to call it just a simple 360 camera, but if you're referring to just a simple 360 camera, there's a bunch of them out there. We happen to use the Ricoh Theta for taking measurements or taking photos, 360 photos on site. If you're referring to a scanner that does 360 photos, like the photogrammetry, the Leica has a number of different products out there. I actually will kind of defer to Colin a little bit because he's been around it a little longer. He may have additional input.
Yeah, no, you got to discern between photogrammetry and actual points and point clouds. So I think the question is about 3D photos. So you can either get the handheld Theta, which is a really inexpensive option. Matterport scanners are another option that I'm sure you're all familiar with. You've seen them on all the real estate websites. And yeah, if you want to collect point clouds and photogrammetry, like Justin mentioned, the BLK that we talked about in the presentation is excellent. And that's going to cost you up into the tens of thousands of dollars.
Thank you. I want to answer these in order that they came in. Hopefully that answered your question about the 360 camera. Repeat how to use a zip level. The audience distracted from the presentation.
Yeah, I'll take that one too. Zip level, I've got another person on here that says they love their zip level. I love my zip level. It's really simple. It uses displacement to give you height readings digitally. There's liquid and gas inside of it, and it's connected to a 50-foot cable. You connect the readout to a unipod, a one-legged tripod, and you just walk around and it gives you a reading. And what you do is you zero it somewhere, like the front door entry finished floor. And then you can go anywhere you want within 50 feet and just get the difference in height in whatever units you choose to take spot elevations, essentially. So it's a great tool. You want to get it calibrated once a year. Send it back in to get it calibrated, make sure it's working right.
Thank you, Colin. Hopefully that answered your question. And if you have more questions, we can certainly answer them outside of this presentation if we run out of time. Scanning options, the newer iPhone and iPads. So what my experiences have been, and I know Colin has looked into this a little bit in the past, very little bit after a question was raised to him about that. But I'll say what I know about it, which is the LiDAR on the new iPhones is directional based. So basically you have to point it at an object and go around that object to get the object scanned. The mobile and terrestrial scanners scan in 360 degrees as you're in a space. And so I would, without knowing more about it specifically, I would say that for building purposes and accuracy purposes, iPhone has a little ways to go to get to where the technology is that we use to measure buildings. That'd be my 2 cents on that. How do you manipulate the photos from the 360-degree camera? Well, I guess I'm not sure exactly what you're hoping to manipulate them by, but the software that comes with, like the Ricoh Theta, for example, for just a flat 360, not a flat, but a 360 image, the software that comes with it, you just pan around and you can go in all 360 degrees then to see what's around you wherever you placed it. We usually go around the building and take a bunch of photos, 360 photos. As far as the Leica and the Matterport and things like that, the only real manipulation you do is that each one, the imagery basically has the laser points with it, so you can measure to those points as part of the cloud. At least that's the nuance that I know. So I don't know.
Yeah, I'll just add to what you're saying, Justin. It's important to remember the difference between photogrammetry and actual measured points, because photogrammetry, I've heard of people trying to hack into programs with just 360 photos and actually take that into CAD or Revit to draft from with pretty bad results because you're not using actual measurements, you're just using photographs. So you'll want to be careful with any sort of manipulation in that realm to get your plan set out of it.
Okay, thank you, Colin, for that additional. We have some time for some more questions. It is an hour-and-a-half credit course is what I'm being reminded. So we do have some more time. Are there other questions on traditional surveying methods or the laser scanning technology. So in the time on site or time measuring and drafting, I just wanted to kind of go back to the range that we had for the audience participation. And that's that typically for like a 1,500 square foot house, we're going to be probably maybe 3 hours on site to laser scan it, and then a few hours in CAD once we're back in the office to model it or draft it, rather, I should say. So the people that are doing it in an hour, like Colin said, I would love to hire some of those folks, especially for some of my larger homes that I scan out here on the East Coast. Are there other questions? How do you deal with the mirrors and pendant lights? JP, how do we deal with the mirrors is basically either try to hide them. For example, if they're on the backside of the door or something like that, we just prop the doors open, etc. If they're in any other place, we actually take butcher paper with us and we'll just cover the mirrors or a portion of the mirror. Depending on the scanner, they get more or less confused. And so we just cover them with paper, and that usually is enough to distract them and get them to stay where they're at. And pendant lights, I'll just, sorry, I almost forgot about that part of it. Pendant lights are really not an issue. Basically, anything that is in the space, as Colin mentioned in the smaller items, if it's less than an inch, basically, it's going to have a hard time grabbing the point data. But anything that's in the space, it's going to grab it. So actually, hanging light fixtures are great for reflected ceiling plans because it'll capture all of that and make it a lot easier to get the RCP. Tolerances. Talk more about tolerances. What would you like to know? The mobile scanner that we use for most projects, that Zeb Revo, is a 1/2 inch tolerance. It's accurate to within a 1/2 inch up to about 90 feet, 30 meters. The more open or repetitive the space, the more tricky it can be with keeping with that tolerance. But that's why we take the perimeter measurements to lock in scaling and things. The horizons that we have is actually very similar. It's another mobile scanner. That is accurate up to 90 meters in the same fashion, the 1/2 inch tolerance. The Leica, the big difference in the tolerances with the Leica or the terrestrial scanners and the mobile scanners is that it'll take longer. It collects more data and therefore it can be more accurate, but it does take more time on site. There's more setups, and the time per scan in each location takes a little bit longer. Hopefully that answered your question, James. If you want a follow-up question, please by all means ask it. Tom wants to know, once you have a point cloud, you're essentially tracing over it to create drawings in CAD. More or less. Like I said, we take some hand measurements to kind of make sure that the scaling is correct, but each side of the wall will have, a little bit of cloud data. And so, we have our own standards for how we adjust for that and draw over top of it, and use a little bit of common sense for when things, come up at a dimension that don't make sense. But yeah, essentially we're modeling with objects or drafting over the point cloud lines. Did I miss the pricing? We haven't gone into specific pricing. You please feel free to contact us outside of the program and we can talk pricing. But for contract services, we're pretty competitive. The prices for all contractors that do this kind of thing are varied as the companies are that do it, and the type of equipment that they use. To purchase them, I can tell you that I think, Colin, maybe you know better than I do, but I think like the Zeb Revo is like 50 grand.
The scanner itself is expensive, and the software that you use to process your point clouds is very expensive. So we're talking high tens of thousands of dollars for the mobile scanners and the ZebRevo stuff. And then to touch on tolerances again, I think Faro, which is a company we didn't talk about that makes a scanner, they're now you're approaching $100,000, and they boast 16th inch accuracy. But the problem with it is when you're looking at a point cloud, especially in plan view, even a wall may not be completely plumb and you'll have a little bit of variation there. So it really depends on where you're cutting it and looking at it to be able to get that hyper level of precision if that's what you're trying to get.
Thank you, Colin.
Mm-hmm.
And rental costs, I don't have a specific cost for that. There are some companies that do it, but then you still have to know how to use it, which it takes a little practice to get to know the quirks of each different kind of equipment. So we have some people that in our within PPM that have used a lot of different kinds of equipment and are really good at all of them. We have others that just use certain types of equipment and have gotten really good at it. Luella, hopefully that answered your question. If you want to follow up, that's great as well.
I'll take the zip level.
Oh, what was that?
I'll take the zip level question.
Okay, you got your eyes on it already?
Anytime I get to talk about a zip level on it, yeah. It's why is it better than using a Bosch laser measuring tool? It's not necessarily better, it's just different. You're getting a completely different type of measurement because you can walk around freely, putting it anywhere you want within a 50-foot radius, and it gives you a height difference. You can't do that with a handheld Bosch because you're just kind of shooting down. I'm not aware if Bosch makes anything similar to a zip level. Maybe they do. But if we are talking about laser measuring tools, a point and shoot distance measuring tool, you're going to want to go with the Leica Disto. It's far superior to the Bosch. I would recommend doing that too. It's a little more money, but it's a more reliable tool for sure.
Thank you, Colin.
Mm-hmm.
Ballpark fee to produce as-built drawings for a 3,000 square foot house. As I'm sure you can all appreciate, complexity of the home and the scope of work can vary that greatly. You know, we could talk ranges, but again, I think if you want to know prices, we do have a generic pricing on our website. You know, for floor plans only for 1,200 or 1,000 to 1,200 square feet, start at about $750 for a minimum for floor plans only. Beyond that, scope, complexity, all that comes into play for up from there for scope and size and whatnot. JP, does furniture need to be removed? No. The key thing is we just need to be able to at least get the critical portions of the wall on all sides. We open blinds and curtains and things like that so we can get the edges of windows. But generally speaking, furniture doesn't need to be moved, except for, I will say, if you're doing an electrical plan and we need to measure the locations of outlets and things like that, we might need to move a table or couch or something. James, pick up irregular construction on triangles. Yes, in fact, we have sort of our standards for over certain distances, how much something can be untrue before we actually draw it that way or keep it non-orthogonal. So yeah, it'll pick up that the wall is angled, and I've rescanned projects thinking that it was supposed to be orthogonal and turns out to actually truly not be orthogonal. So it will pick that up. Some people want to have those modeled as irregular or drafted as non-irregular or as irregular. Some people want them to be made true as they quote unquote should be. But we work with all of our clients to figure out what you prefer.
Yeah, exactly. You might get a phone call. Let's just say that.
Yeah, exactly. Question from somebody named Conference. Since the laser technology is line of sight, how do you work in a space with many columns? It really depends on the type of laser scanner that we need to use and the type of space. With the handhelds, we can do a number of things. We try to put things in the space. We might move a chair. We might Put something where it breaks up the monotony of the repetition of columns. There's also these things that are QR codes basically that you can print out. I've done that with the Matterport actually, because that really gets confused with repetition. But yeah, there's a number of different ways that you can handle that. Try to go around them as much as possible. I don't know, maybe Colin, you have some additional things you could add to that, but
yeah, I think the question is more about how do you get the information behind those columns blocking you, and that's simple. You need to weave in and out of the columns and scan all sides of them. And the same can be done with your terrestrial scanner. You just need to set it up in a lot more positions so that you can collect it. So, but you're correct. If the laser can't connect to the object and it's obscured by another thing, then that point is not going to be registered.
Yep. Thanks, Colin, for that added. Helen, you're asking how would you address the desire of small practice architect to be very hands-on in the production of their own drawings and becoming familiar with their subject project, as well as the occupants through the process of hand measuring, observing, and can you address cost-benefit comparison for the same? Great question. So basically, we offer a number of different solutions for that, if you want to call them that. I offer to my clients, have us go out, do the measure, and then you can go out with those drawings in hand to familiarize yourself while you meet with your client. That's one option. I have a couple of clients who at first started to meet with me at the same time, or meet with their client at the same time that I was there to measure. And then they were meeting and familiarizing themselves with the house while I was getting the measurements for them. We provide still photos as standard with our deliverables. So you get the photos so you can walk through the house while you're looking at our plans. We've had clients, and I don't know if Cameron is still on, but Cameron was on for a little bit. He's our regional director for the Southern California office. I know he's had a client that actually went from getting the full set of as-builts to getting the point cloud to going back to getting the as-builts because they decided that they went back and forth on what they thought they needed or wanted. So maybe Cameron could hop in on that one too, but yeah, we'll work with you however you want to work to still do what you need to do. I know that the as-built process is a big part of understanding the building, but also it can take a lot of time. So we're happy to free up some of that time, and you can still meet with your client and familiarize yourself with the building.
Yeah, and as Justin suggested, if you do later go to the site with plans in hand, then you get to spend that time getting to know the occupants, and maybe by that time you'll have some particular questions that you saw in plan view that you can really focus on, and you don't have to spend all that time measuring every little thing, and you get to skip that. And just to address the cost benefit comparisons, I like to just ask, think about it in terms of your hourly. If you're hourly to travel to the site, measure it, draft it or model it, and then at that point get started on your design is more than what we're offering to do that same thing for, then that's something to consider. And our goal is to always be lower than that. And we usually are. So.
Thank you, Colin. Appreciate that.
Justin, do you want to stop screen sharing for just a moment and go to gallery view, and we can kind of see the faces in the group? And
sure, happy to do that.
It's a vertical measuring tape, I think. Let's see.
I think that was just a comment. But Mike, if you had a further clarification on that you wanted to say, by all means, please, unmute and pipe in if you want. Do you do certified as-built drawings? If you're referring to Boma, yes and no. We don't do it really as much as we used to. We often will actually refer it out. But that's what you're referring to.
We can measure to Boma standards and provide a CAD file to Boma standards, but creating that packet that you might be used to if you're a commercial architect that has all the square footage breakdowns. That's kind of an entirely different profession. So we usually look to others, and we have tons of partners that we work with in that capacity.
Thank you, Colin. What typically would be the cost to do as-built for an elementary school, say? Again, I think look at our ballpark pricing on our website. An elementary school is a fairly reasonably large size project. We'd probably want to know more. Colin, I don't know, you've dealt a little more in schools with our services than I have, but I wouldn't even want to throw numbers out.
Sure. I've measured a couple schools recently. They're shut down, and if they have the means, they're looking to improve them in the meantime. So it's definitely tough to give you a typical cost for a school, because we always look at the structure itself, and the fees are based on the sheer size, the square footage. The scope of work that you need is a big needle mover, and then the complexity of the structure. But I will say that there's economies of scale. So the more ground we're covering, the lower the cost will be, at least per square foot in most cases. And, you know, if your school is a giant rectangle, if it's just one big open gymnasium, it's going to cost much less than something more intricate that's got, you know, cathedrals and things like that going on. So I would suggest getting a quote, because quotes are always free, and we're happy to give them out for whatever project you have.
I would also say that our quotes typically get turned around within 1 to 2 business days. So we're usually pretty quick. So if you need a ballpark number on a specific property, we're usually pretty quick to turn it around.
It looks like Cameron gave a great answer
In the chat.
from his perspective in the chat, if you want to read that about that other question.
Sure, I'll read it. So to follow up on the go into the site and things, you can always provide point cloud data, site photos ahead of final plan delivery and almost instantaneously after field visit to assist the clients in familiarizing themselves with their project as early as possible. And that also comes as no additional cost to provide that in addition to the rest of the deliverable. That's a lot of questions. We have more time. Are there any other questions, or did we miss any?
Yeah, to the individual that asked to share the website and contact info, that's been pasted into the chat as well, if you're looking for that.
Thank you, Colin. And I can also re-screen share before we're done with some contact information in a little bit, but
Justin and Colin, maybe just to let everyone know, also we'll follow up with the deck so you all have a copy of it and provide some contact information in there as well. After it'll probably come to you probably tomorrow.
sure. So there are a couple of additional questions that popped in here. One is, did you mention Matterport? Yes, we both alluded to it. I'd actually probably do more of them in this area than our other areas all combined. There seems to be a greater desire on the East Coast here for it. I will say a couple of things about Matterport. It's great for what it is. We do not rely on them for as-builts. The accuracy just isn't quite there. But they're a great virtual tour tool. I have a couple of clients who have them as standard with the rest of their deliverable on every project so that they can do exactly what we mentioned before, familiarize themselves with the house. And during COVID now, it allows contractors and others to get in the properties as well without having to actually physically be there. I will also say, though, that it is not a core service of ours. We do add it as sort of an extra, but because we rely on the LiDAR technology and other things for accuracy, that's not our primary tool. Do you cover New Jersey? Yes, we have. So I should say a little bit more about our company. We are based in Southern California, but we have regional offices in other places, such as the DC area. And depending on where in New Jersey, we can either cover it directly from the regional office here in the DC area, or we do have a national team, if you will. We call them special operations. They handle all of our large multi-site or any project that happens anywhere that we don't necessarily have a firm office presence. They'll manage projects anywhere. So basically we have 50 state coverage, but from the DC area here, I cover basically roughly 3 hours-ish from the DC metro area. How do you handle covering the variances that happen when measuring a historic structure without level floors? There's a few different ways, and we kind of covered it with the wall variances as well. But basically, if it's over a certain pitch, we'll call you and say, do you want to show it with a 3-inch pitch from one side of the room to the other, or do you want to show it as level? We have our kind of standard tolerances and on where we keep it level, and then beyond that, we always ask the client. So it's really kind of up to you how you want to show it.
Yeah, a section cut would be the thing that comes to mind for me, having it in the place with the most variance. So that way you can just see that visually and measure it using the distance tools and things like that.
Yep. Thank you, Lauren, for that question. Any other questions, or did I miss any? We've got about 10 minutes left. If anybody has any additional questions, comments, concerns.
I just want to mention that you all did the Matterport of the Leaf House, which is the AIA Potomac Valley Chapter House. I don't know if Sue mentioned that at the outset, but that is something everybody can look at. Certainly people who have been to the Leaf House, which was the 2007 entry by the University of Maryland in the solar decathlon, and they won second place in that. Subsequently, I think it's 2011, by the way, University of Maryland won first place. Kept trying and eventually did win, but it's a very interesting structure, and it is fully portrayed in a Matterport that was done by PPM very generously to, it's very beneficial for everybody who loves three-dimensional representations, and it does show what that capability is. So have a look at the chapter.
And you can even see on that one, if you go to that the Leaf House Matterport, you can actually see how you can use the measuring tool. And it, like I said, it is fine for what it is. It's not uber accurate, but it gives you a rough sense of the space and ability to measure. And like what we did with Leaf House, you can actually do it as part of a tour. We also did it with AIA Northern Virginia with the Heights building, and they're utilizing some other functions and features of it too as part of a post-project tour, if you will. So does have some great things, and as Helen said, you can see some of the capabilities there.
Well, it sounds like everybody is questioned, asked everything they want. Last chance, everybody. If you have anything that you want to ask, don't be afraid. This is a good chance.
And if there are questions that you're afraid to ask in the group but would like to ask anyway, please feel free to reach out to us, reach out to me, send me a email or call me or whatever. I'm happy to answer questions at another time as well.
Right. Well, with that, thank you all for a very interesting program. I think it's going to be giving a lot of people a lot to think about, and I suspect you'll get more questions. Yes, be sure to see the chat box if you want to save the information and about the contact information, that is. And I want to thank our sponsors again, including PPM, for making this program possible, and as well as Barron's and TW Perry. And look forward to seeing you all in the next program.
And I would just like to add as well, thank you so much for allowing us to give this class and presentation, and we appreciate everybody's interest and desire to get on and listen to us talk about what we're so passionate about. So thank you for that.